Well, hi everyone, and welcome to transitioning from ROBOTC to VEX Coding Studio Week 2. My name is Jesse Flott, and I will be the presenter tonight. Today we're going to discuss a few topics. We're going to cover a few questions that were pretty popular just from the comments sections and Twitter and other places. We are going to focus on transitioning from ROBOTC to VEX C++, specifically around commands that use motors and encoders. And then finally, we are going to cover some additional topics, show you some additional resources to help you get started with VEX Coding Studio. So one very popular question was around troubleshooting and debugging inside of VEX Coding Studio. There were a handful of questions asking how to compile code, how to know whenever you had error messages, those kinds of things. And VEX Coding Studio actually has some really good support inside of the application. So if you are working on a program, and even if you don't have a physical robot connected to your computer, you can click the download button and it will compile your code. So it will also, look for a robot and detect that it's not there. But prior to doing that, it will compile your code and check for any error messages. So what it will do is anywhere that it finds an error message, it will put a red X on that line. If you were used to ROBOTC, this will be familiar to you, where we had a red X on that line. But a big improvement is that it gives you error information in context. So if you mouse over, if you put your cursor over that red X, it will actually give you some help. It will give you some suggestions, help you diagnose what's going on that line. So instead of having to look at the bottom of the program and scroll up and scan up, you can see those issues directly in context. So that's really nice. The other thing is that there is a console window still at the bottom. By default, it is tucked in the bottom, but you can click and drag it up. And so whenever you do things like download, it generates console messages or console logs. And if you have errors inside of your code, those logs will show up as red. And so you can see the error messages up above, and you can also get a full list of any errors that it detects down below. Another very common question was around getting started and sample code. So VEX Coding Studio does come with a fair amount of sample programs for both ModKit, VEX C++, and C++ Pro. Whenever you open up VEX Coding Studio, or whenever you start a new project, if you notice the button named Example Projects, that takes you to the Sample Programs directory, or selection screen, if you will. It's separated by the application, so whether it's motion, sensors, controller, competition, things like that. So you can click on the section, click Choose, and then it will take you to a folder where you can choose between examples written in ModKit, VEX C++, and C++ Pro. So all of those supports are in there for you to help you get started. All right, for the next section, we will take a look at some existing ROBOTC code and how that translates over to VEX Coding Studio code, specifically VEX C++. These pictures and a lot of additional information can be found at the URL here. This is with the STEM labs available on the VEX website. All right, so if you were familiar with ROBOTC, maybe you had some programs that looked like the one at the top up here, moving forward based on time, where we have a program. Begins with task main. We have motor commands. We have the wait when msec command, and then more motor commands to turn the motors off. Well, this program translates very nicely over to VEX Coding Studio. there are different keywords, but the logic, the sequence, the flow is very, very similar. What we've done is we've put numbers next to kind of the analogous portions. So here, where I have the number 1, up at the top, that's task main. Task main is the main task or the main structure of my program. In VEX Coding Studio, very similar, but it's called int main. And that's a standard C++ thing, that your program will begin executing, the program flow starts at the beginning of int main. So instead of remembering task main, just remember int main. Number 2 is the motor command. These were the commands that allowed you to specify which motor you wanted to turn on and at what motor power level. Well, in VEX Coding Studio, you use the spin command. The spin command, similarly, lets you choose which motor and also power, and we have some advantages inside of VEX C++ as well. So notice that the spin command, though, doesn't come first inside of the line. So in ROBOTC, the motor command was the first thing to show up in the line, but in VEX Coding Studio, the spin command is not. Instead, the first thing that you reference is which motor. Okay, so in ROBOTC, you did that in between the square brackets. In VEX Coding Studio, since C++ is considered a object-oriented language, VEX Coding Studio, VEX C++ uses something called dot notation, which is a way of representing data and objects and properties inside of programming. So instead of starting with the spin command, instead you will always start with the motor that you want to spin. So here I have left motor and right motor dot spin. The names of the motors are specified on that robot config screen that we looked at last week. Okay. Whenever I wanted to choose what power level inside of ROBOTC, I could just say equals a number and then semicolon. That number ranged from -127 for full power reverse to +127 for full power forward. Inside of VEX Coding Studio, in between the parentheses, what we have are a few parameters to choose from. We can first specify direction type. So here in our program, both motors are set to direction type FWD, or forward. The next parameter is a percentage of the power. So here 50 would be half power. And then the last parameter, we can actually specify a velocity unit. So here we're specifying %, but you could also choose RPM. So if you needed to choose a specific rate and not just a percentage of speed, you could do that inside of VEX Coding Studio. A lot of this is possible because each of the motors do have the built-in encoders. All of the smart motors have built-in encoders, so it's able to modulate its speed, control its speed with those automatically. So a difference between ROBOTC and VEX Coding Studio is in ROBOTC we were choosing 63, and that's because that was like a raw number between 0 and 127. But in VEX Coding Studio, we are choosing 50 because that's 50%. So that's the difference for the number. Next to the number 5, we have the wait 1 msec command, which doesn't make your robot stop and wait. It's kind of the keep doing what you were doing command. It holds the robot's program flow at that spot for the designated number of milliseconds. Well, the similar command inside of VEX Coding Studio is task : sleep with the specified amount of milliseconds. So it works exactly the same way as wait 1 msec. It holds the robot's execution, the program flow directly at that spot before it can move on inside of the program. All right, and then last but not least, we had another set of motor commands for turning off the motors inside of ROBOTC. We turn them off by setting the motors equal to 0. inside of VEX Coding Studio, there is a distinct stop command. So here we say left motor dot stop and right motor dot stop. Okay, and so the spin command allows you to choose how much power and at what rate. The stop command goes ahead and it stops the motor. And then as a parameter within the stop command, you can also choose how you want the motors to brake. B-R-A-K-E, not B-R-E-A-K. So you can have them coast, or you can have them actually apply braking power so that it stops on a dime. All right, this program should look very, very similar. Instead of moving forward for time, this is turning for time. Inside of ROBOTC, whenever we wanted the robot to turn, we would give the motors different amounts of power. So here you can see next to the number 4 that I have my left motor equal to -63. Okay, so that would have created a turn towards the left for my robot. Inside of VEX Coding Studio, inside of C++, notice that we're still using the spin command. And next to the direction type, instead of them both being forward, we have the left motor, its direction type, set to rev, or reverse. So notice that we didn't have to say -50 for the percentage. We can just change the direction type to reverse, and that will cause one motor to go forward and one motor to get backward. Okay. Another type of movement with the VEX system, if you had a integrated encoders, or if you had the integrated encoders on your drivetrain, was moving forward to a target. So instead of saying turn on my motors, hold program flow for this amount of time, and then stop the motors, you could actually tell your motors to go to a certain position or a certain number of encoder counts, and the robot would drive up to that target and then slow to a stop. Okay, so that was possible inside of ROBOTC with the VEX Cortex, but only if you had the integrated encoders. Inside of VEX Coding Studio, since every single one of the smart motors has the built-in encoders, you are able to do this inside of every single program with every robot. So that's really nice that the new smart motors contain those encoders. As with the other programs, the main control structure inside of ROBOTC was task main. Inside of VEX Coding Studio, it's still int main. Inside of ROBOTC, whenever we wanted the robot to move to a target, whenever we wanted motors to spin to a target, we used the move motor target command. The move motor target command allowed us to specify a motor next to number 3, a target number of encoder counts next to number 4, a desired speed next to number 5, and then a braking mode, whether the robot should brake at the end or coast at the end, next to number 6. Inside of VEX Coding Studio, the braking is its own command. You set the braking type for the entire program if you want to. So if we're looking at the VEX Coding Studio program, the first number that we see after 1 is actually 6. And that's because we are using the set stopping command to determine what the default braking type or the default stopping type is for that entire program. And so as with the spin command and the stop command, it starts with the name of the motor, then the set stopping command, and then brake type, brake. So if we want it to brake at the end versus coast, we can use those commands, and then it's set for the entire program. And then the kind of equivalent of the move motor target command inside of VEX Coding Studio is the start rotate 4. Okay, so start rotate 4 starts the motors rotating for a specific number of encoder counts. So what it will do is it will look at whatever the current value is and then add or subtract that on. Okay, so here we're still saying 720 for the number of encoder counts. We get to specify the rotation units. Here we're specifying degrees, which I'm using synonymously with encoder counts, but you could also do rotations. And then we're also specifying the amount of speed, 50, and then velocity units %. So you're able to accomplish very similar things with the motors inside of VEX Coding Studio as you could with VEX or with ROBOTC. An important thing to realize about these programs is with both the move motor target and the start rotate 4 commands, they did not hold program flow. They did not wait for the robot to complete this movement before moving on in the program. So that means if you want the robot to actually complete this movement, if you want the robot to actually make it to the target encoder count or number of degrees, then you have to give it the time or you have to give it the signal in order to do so. You have to allow the robot to reach that point before you give it another command or before the program ends. So that's why inside of both of these programs, we have a while loop. Okay, a while loop is exactly the same in ROBOTC as it is in VEX C++. The while loop's job inside of this program is to just hold the robot's program flow until the motors have actually reached their target encoder counts or target number of degrees. Inside of ROBOTC, we said while get motor target completed, right motor equals false, or get motor target left motor equals false. And so what that did is it checked the motors, and while they hadn't reached the target, the while loop would keep running. Well, very similar inside of VCS, except the syntax is actually a little bit shorter, a little bit simpler. It's while the left motor is spinning or the right motor is spinning. So that is spinning command just checks whether a motor is still spinning. And if it is, then the while loop knows it hasn't reached its destination. And so that keeps the program from moving on. It allows the robot to finish its movement. But again, very similar structure to the program, very similar logic, even very similar values, just a few different commands to work with inside of VEX Coding Studio. Next up, we have autonomous arm movement. So this is if you were programming your robot's arm, not with remote control, but if it was doing an autonomous routine. Inside of ROBOTC, assuming that you had an encoder on that arm, you could still use the move motor target command. You can specify which motor, the number of encoder counts, the desired speed, and the braking mode at the end. Now, the thing that you have to keep in mind whenever you are programming an arm or a claw is that you are dealing with a finite range of motion, right? Very few arms, and I don't think any claws can continuously spin. So that means that if you ask the motor to go to a position that it can't reach, you can stall out your program. You can hold the program flow forever, and then you don't execute any of the commands afterwards. So inside of ROBOTC, one way that we could tackle that is a wait1mset command. So instead of waiting for the target to be reached, and instead of waiting for it to be completed, what you could do is you could just provide a certain amount of time. And then whether or not the arm reached that position, after 5 seconds, it would move on. So that would keep your program from stalling out. Okay. Inside of VEX Coding Studio, it's similar, but structured a little bit differently. What we do is we set the stopping mode again. First, we set the break type this time actually to hold. Because whenever you're working with an arm, the arm is quite possibly fighting gravity. So if you get the arm to go to a specific position, you want it to continue to draw power to hold it there. The smart motors and VEX Coding Studio let you do that. So previously, we would set the break type to break in ROBOTC. In VEX Coding Studio, what we want to do is set break type hold, and that will continue to draw power to the motor to hold that position. Next to number 7 in VEX Coding Studio, there's also a dedicated command for setting a timeout, which is set timeout. So we can say arm motor.set timeout, and then you can specify an amount of time. Here we specify 5, and then in time units, 5 seconds. Okay, so that means whatever movement we want the arm to do, if it doesn't complete it within 5 seconds, it knows to time out that movement. And then finally, instead of the move motor target, inside of VEX Coding Studio, there is a rotate to command where it tries to rotate the arm or it tries to rotate the motor to a specific encoder count or a specific number of degrees. So here we're still saying 630. Rotation units is in degrees, and it's 50% speed. Okay, so rotate to is really nice because it looks at what the current value is, and it doesn't add it on. It does not add on where you want to go to. It looks at where you're at and then goes to the difference. So if you were at 510, it adds 120 on and then rotates the motor to that, if that makes sense. So rotate to is different than rotate for. Rotate for looks at your current value and adds and subtracts the whole number that you specify on. Rotate to, on the other hand, goes to like an absolute position value. So that's what's happening here. Okay, and then this program is autonomous claw control, and it should look very, very similar to the arm control because it's very similar code. The only difference here is numbers. The important thing to take away from claws and arms is that you are working with a finite range of motion. And so you don't want to time out your program. You don't want to stall out your program, I should say, by asking your claw, by asking your arm to rotate to a position that it can't reach. Furthermore, with these new smart motors, they're a good deal stronger than the previous generation of motors. It's possible to damage some of the other components on your robot if you ask it to go to a position that it can't reach. So setting these timeouts is very important. The other thing that you can do inside of VEX Coding Studio, which is pretty cool, is in addition to controlling the velocity of a motor, you can also control the torque of the motor. So if you need a more delicate application, if you want to make sure you're not damaging your components, there are also commands that allow you to control the torque provided to a motor. All right, and then what I want to do is point you to some additional resources that you can use between now and the next webinar, and also answer any questions that may come inside of the chat box. So a really powerful reference is the VEX Coding Studio API. Every single command inside of VEX Coding Studio, whether you're using ModKit, VEX C++, or C++ Pro, is documented inside of there. So if you have some programming experience, this can be a really valuable tool where, hey, I want to know what I can do with motors, or I want to know what I can do with sensors. You can look up all of the associated commands there, along with some description, and it's very helpful. The other resource are the VEX STEM Labs. These are smaller engagements of curriculum. They are focused around different subjects inside of STEM. Some of them are focused around programming. Others are focused around things like math. And so if you're looking for more step-by-step curriculum for how to learn how to program in VEX Coding Studio, several of these STEM labs do have tutorials for VEX C++ and also ModKit blocks. So this is also a great resource that is available to you. Okay, so now I want to open it up for Q&A, and then remind you, we will, if you are a teacher or if you are a coach, we will be offering our traditional professional development around the VEX V5. Check out our website, cmu.edu/Robotics Academy, to learn about those opportunities. All right, so Q&A, not too much today. What is the command to adjust the torque on the smart motors? Sure, so let me actually open up VEX Coding Studio. So one really nice thing about VEX Coding Studio is the library of commands that it shows up is based on what devices that you have on your robot, which devices you have configured for your robot. So here, if I configure a motor, I can go inside of my text mode, okay, and setting the torque would be a setting, and the command is motor name dot set max torque. Okay, so if I wanted to set my max torque to just, let's say 33%, I can say motor1 dot set max torque, file that to get rid of the error message, and then for the whole program, that limits the torque to your motor. Okay, any other questions out there? Feel free to put them in the chat. All right, well, if there are no more questions during the live session, feel free to post your comments, your questions as comments with the YouTube page. We will do our best to answer those and also address them during any future webinars. Oh, another question came in from Griffith Griff. Do you need to reset the encoders on the motors? Well, the answer is it depends. You certainly can reset the rotation of the encoders. There's this motor.reset rotation. Okay, so it's the name of the motor and then reset rotation, and that will reset it to 0. Now, whether or not you need to depends on your application. For example, if you are programming a robot's arm, sometimes it is nice to not reset the rotation between each autonomous movement of the arm. You know, if you start the arm in the lowered position and you raise it a certain amount, it's nice to be able to say rotate to 0, and then you know it's going all the way back to the starting position of the arm. Similar applications for the robot driving around. It depends. You know, if you want to make sure that the encoders start counting at 0 for every movement, you by all means can reset them. But the the start rotate 4 command takes whatever the current encoder reading is, and then adds or subtracts on the desired number of degrees, so that you do not have to reset the commands, or you do not have to reset the encoders. Okay, so it depends on your application, but the rotate 4 won't mess you up if you just specify the number. Rotate 2 goes to a specific encoder reading. So you have to think about your application a little bit more. Okay, from Gonzalo, what are the commands to get the values from the sensors and encoders? Thinking on saving it to a variable? Sure, so actually inside of VEX Coding Studio, the commands are broken up as settings, actions, and sensing. So if you click on sensing, what you will see is you can access lots of different values from the motors. There's motor.rotation, motor.velocity, motor.current, .power, .torque, .efficiency, .temperature. So any of those values are accessible, and you can store them inside of a variable. You can use them in an equation, whatever you had in mind, but you can access them there. The trick is really just clicking on sensing, and you can see everything that's available. Okay, from Gadil, is there a max number of degrees an encoder can count up to? Not that I've heard. I'm sure there is a theoretical maximum number, but I'm sure that's a really big number. And it might be in the documentation somewhere, but I don't have that answer off the top of my head, sorry. All right, well, thanks again, everyone, for joining the webinar. Again, do feel free to post any questions that you have, and we will do our best to get back to you.